Hello everyone, welcome to the channel Understanding.Concepts.Of.Physics. Subscribe the channel in case you have not done so, and keep watching the videos from the playlist so that you can understand the concepts better. Just one of concept in the middle might feel you uncomfortable, so watch it in a series. Now we are doing topic on waves, and in the past few 5 to 10 videos we have been discussing about waves, and today we are going to discuss a very small topic. Today's video is going to be very small, that is velocity of a transverse wave and velocity of sound, that is the longitudinal wave. Okay, now why I'm doing this topic separately, because I want to start harmonics and overtones and vibration of the string in the coming videos. That's the reason why I've taken this thing. So velocity of a transverse wave on a string is given by v is equal to square root of t by m, where t stands for tension, where v is the velocity of a transverse wave, t stands for tension, and m stands for linear density. Now m is sometimes called as linear density, or it is sometimes called as mass per unit length. So it has two names, either it is mass per unit length, or you say also a linear density. Now in some books you will find out that this linear density or the mass per unit length is written as lambda, and that is perfectly fine, and that is also mass per unit length, that is m upon L. Now just remember that I have not written over here, but yes, we should have written it somewhere around here. I'll just make that thing. Now, so this capital M is basically mass of string, okay, and L is the length of string. So when a transverse wave travels from one point to another point, the mass is m, and mass of the string is capital M, and the total length is L. So if you divide the total mass, which will be some in grams, some might be in kg as well, depending upon how long your length of string is. Okay, so this is our string, then the total mass of the string divided by total length of that string will give you the mass per unit length. So it is sometimes written as lambda, as well as sometimes written as capital M, sometimes written as small m. Okay, now this is what about velocity of a transverse wave is. And so when we start the concept of vibration on a string, we'll be utilizing this formula for velocity. Okay, on the contrary, we have velocity of sound, that is longitudinal wave. Now this is not a very holistic video for velocity of sound. I need to discuss about Newton's formula and those stuffs, but this video is specifically for superposition of waves and vibration of air column, and that's the reason we are not discussing about Newton's formula. I'm just directly writing velocity of a sound is equal to square root of gamma p by rho, where gamma, p and rho, what are these? We have discussed here. Now this is actually corrected formula, so this is called as the Laplace's correction, and Laplace actually corrected Newton's formula. He actually corrected Newton's formula. That's the reason why it is called as Laplace's correction. Okay, so anyway, we will discuss that thing in some other video. As of now, we have just understood that, okay, we have this gamma p by rho. So v is the velocity of sound, gamma is the ratio of molar specific heat at a constant pressure and volume. So remember that, okay, gamma, this is not r, this is gamma. Okay, it's a Greek letter. So gamma is the ratio of specific heat. So ratio of specific heat is written like this. So gamma is equal to ratio of molar specific heat at a constant pressure and molar specific heat at a constant volume. So what is Cp and Cv? Cp is molar specific heat at a constant pressure, and Cv is molar specific heat at a constant volume. And in my formula, rho is the density. So density I have written as rho is the density. Now remember that, okay, in this video it's not possible for me to explain the entire molar specific heat, what it is. It actually goes into thermal physics, okay, what molar specific heat is. So when I start with thermal physics, I'll explain it to you what molar specific heat is, what principal specific heat is, or heat capacity is. So as of now, you just remember that this gamma is basically the ratio of specific heat. Gamma is basically a signature of a kind of a gas. So if the gas is monoatomic, the medium or the where the sound is traveling, if it is monoatomic, then this gamma value has a fixed number. If it is a diatomic gas, then we have a specific value of this gamma, and if it is a polyatomic gas, we have the specific value of that. Okay, so anyway, right now you just have to remember that it's the ratio of a specific heat. When we do thermal physics, we'll come to this part in the detail. Then comes to the velocity of sound in air at 0 degrees Celsius. Remember that in air, because the medium actually affects the velocity of sound, and temperature also affects, so that's why I've written here, okay, velocity and in air at 0 degrees Celsius is coming out to be 332 meters per second. This is in meters per second, remember that, which is way less than the velocity of light, that is 3 into 10 raised to 8 meter per second, that is somewhere around 300, 00, 00 and 00, so like a lot of meters per second. So sound is traveling much slower than velocity of light. So that's what is for today's video. We have discussed about transverse wave and velocity of a transverse wave on a string, and we have discussed about the velocity of a longitudinal wave or the sound wave. Okay, thank you so much for watching. In case you have not subscribed my channel yet, subscribe the channel and keep following me. Also share the channel with other people who might get benefit out of it. Thank you so much. Have a nice day. Bye.